Okay, mathematical induction. I'm just going to do a couple of questions that to clear some understandings here. First one was when do I use n equals k plus 2, not n equals k plus 1? Now, this is what step 3, that when we do prove true for n equals k plus 1. And that's like sort of standard way of doing n equals k plus 1, but sometimes you have to do n equals k plus 2. And when do we do that? Now, these sort of related is when the proof is something to do with even or odd. So you need to think about that. So first example is p of n is what? 5 to power of n minus 1 is divisible by 8 for all even integers, that is n is a bigger or equal to 2. Okay, so first thing first, what are the n values here? So we got 2 is included, and then it has to be even after that. So 2, 4, 6, and so on. Okay, so first step, we need to use n equals 2, don't we? You don't use n equals 1 because it's not included in there. So that's okay. So minimum integer you can use is n equals 2. That was a step 1. Now step 3, that's the part that we need to think about a little bit more. Now, prove true for n equals k plus 1 is normal. So you have choice here, n equals k plus 1 or n equals k plus 2. Now, why do I have these two choices? Think about. Let's think about if I use n equals k plus 1 and k is n from step 2. So these are my n and k's, yeah? So I will put 2, 4, 6, something like that, plus 1, plus 1, plus 1. What do I get? I get 3, 5, 7. And all these are odd numbers, yeah? And that's not really what we want. We want it to prove to be all even, okay? So we can't use n equals k plus 1 to prove this because we're not going to get even. But if I use n equals k plus 2, the next number, so still k value will be 2, 4, 6, and I'm going to add 2 instead of 1. Now, if I do that, I will get 4, 6, 8, we get even. Okay, so therefore, we need to use n equals k plus 2 instead of n equals k plus 1. Okay, so that's why we need to use it. And second one, very similar, but this time it's odd integers, yeah? And what is the minimum n we can use? The integer is 3, n equals 3. So, and then it has to be odd afterwards, so it'll be 3, 5, 7, dot, dot, dot. Okay, so let's have a look at that. Step 3 again. If I use n equals k plus 1 and n equals k plus 2, so we know the k is going to be all odd numbers from 3, so it'll be 3, 5, 7. I'm just going to defer 3, plus 1, plus 1, plus 1. What will I get? I will get n is what? 4, 6, 8. Now that's even, yeah? And that's not what we want. So definitely we can't use n equals k plus 1 to prove it. Now, if I go to the next one, because, you know, the numbers are in order of like what? Odd, even, like a 1, 2, 3, 4. So to make it odd, I'm just going to add one more here. So it'll be 3, 5, 7, plus, 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 2, 2, 2. So what do I get? Here I get 5, I get 7, I get 9. So these are odd numbers, okay? So again, for this proof, step 3, I will use proof true for n equals k plus 2, not plus 1, okay? So that's how you decide which one you go with. Okay, the second question is the when do I use when k is not 1, the starting is not 1, what does that mean? Okay, so there was some confusion there, and I think I did make a mistake on the previous video, so I'm just gonna correct this one. So k equals 3, that's the first term, okay, and it goes up to, it's not up to here, but k equals 6, it's going up to when k equals 6, that's what it means. So it'll be k equals what, 3, 4, 5, 6. So there's 4 terms there, okay, you're going up to that. So here it'll be I'm gonna do 1 over 3, start with 3 to power 1 plus, because it's a sum, 1 over 3, 4 minus 1, 1 over 3 to the power of 5 minus 1, plus 1, 3 to 6 minus 1, and stop there, okay? Now, that 6 doesn't mean it goes, there's a 6 terms. It doesn't mean 6 terms. It just goes up to 6, okay? So be careful with that. And what I'm going to do here, it'll be, I'm not going to give you an answer. You can just use your calculator. I'm just going to tidy it up a little bit. So it'll be 3 to the power of 2, 1 to 3 to the power of 3, 3 to the power of 4, 3 to the power of 5. And that's it, okay? And then you will get the answer here, all right? So there's 4 terms. Starting is 3, the last one is 6. So that's what we did. 3, 4, 5, 6. Okay, so that's not too bad. The second one. Okay, so k is 4, that's my first one. And then it goes up to 8. So 4, 5, 6, 7, 8. So what's it? 5 terms right there. So let's have a look. Minus 1, that's got 4 minus 1. 4 squared, plus, I'm going to go plus, so 4, 5, 6, 7, okay, and then I'll just put all that in so I can concentrate on the terms there. So 4, so it'll be 5 minus 1, the power of 5 minus 1, power of 6 minus 1, 7 minus 1, okay. So I'm just going to tie this one up a little. So what do I get? It's minus 1 to the power of 3, 4 squared, plus power of 4, 5 squared, power of 5, power of 6. Okay, so I will go, again, I'm not going to do the answer. You can just do it yourself. I'm just going to make it quick. So what's that? 4 times 4, 16, 5 squared, 25, 36, 49. Now that's minus 1, that's plus 1, minus 1, that's 1. Okay, so roughly minus 1 over 16, plus 1 over 25, minus 1 over 36, plus 1 over 49, and the answer. Okay, so this is what you've got to do. So this is like a starting term. K equals 4, it goes up to 8. When it's 8, we stop. Okay, excellent. Thank you.